machine that's running here is our G1 kit. In August of 2014, I produced about 5 videos of this machine. The first one was an introduction video, and the next 4 were demonstration videos that showed input, output, and also it showed an unusual little recharging ability. And I had always just considered that a side effect. It was no big deal. Some people even thought it was a hoax. They just didn't understand how it was possible that it could do what it was doing. But over the years, this will be the 3rd time that I've shown this aspect on the internet or on YouTube. Now, I don't think anyone else has ever shown this, and if they have and you've seen a video of it, please send me a link. I'd love to see it. So what I've done here is I've isolated this section right in here, which is basically everything on the left side of the flywheel. And I put it into a separate cabinet so I can show you this process one more time. And maybe the last time I show it, I don't know, but just pay close attention if you're interested in this, and we'll go through it. Now, here's the machine that I isolated it into, and you can see I'll just leave this kind of show in the background there because it's just the 3-phase that we're interested in. Now, this machine is a little bit different because it's just, of course, it has the 3-phase here, but it's going to be run by a motor. And the motor will just represent the rest of the G1 as far as the 4 rotors and coils and magnets and things that make it rotate. So we're just going to use this. And what I'm going to do now is I'm going to just identify the parts that's in this for you, and then I'm going to describe what you're actually going to see happen when we fire this thing up and run it through its paces. It's a delayed chemical reaction actually, and so it takes maybe a minute or 2 to kick in. And I've got a clock here that I'm going to put into the video so that as a point of reference in case I need to speed this up, because sometimes it takes 15-20 minutes for it to reach its maximum goal. What we're going to do is we're going to drive this machine up to a certain voltage. I'll go over that in just a second. So beginning, what we've got is, again, we've got this motor, and we've got the 3-phase, 2 AGM batteries here, 2 ultracapacitor modules here and here. There's 350 farads in each one of these 6 sections of each one of the modules. And I've got a pulse width modulator circuit, just simple little circuit that just keeps this within its range. It's a 12-volt motor, DC. And I've got 3 bridge rectifiers that convert the AC off the 3-phase back into DC that feeds back into the system. Okay, so the way this is connected is this battery is labeled battery A. I don't know if you can read that, but anyway, this is labeled A, and this is cap module A. The 2 are in parallel. This is labeled battery B, and the cap module in the back, let me see if that's in the frame. I pull it over just a little bit for you. Okay. So cap module B is in parallel with battery B. All right, then these 2 batteries are connected in series. There's a little jumper wire here, you might not be able to see it. And these 2 cap modules are also connected in series. So this entire unit acts as well, it acts as one unit because it's series parallel connected, but whatever the voltage is in this battery, it's going to be almost identical in this battery and almost identical in this cap and almost identical in this cap module. So it's going to be a unit. It's just going to act as that. So whatever the charge is, what you see right here, 2635, that represents everything in series. And what we're going to do, well, basically that would be 13.16 or 17 volts per battery, which is fine. That's typical standing voltage for these AGM batteries. And what we're going to do is we're going to drive these up to 29.5 29.6, and that'll be roughly, when they settle down, that'll bring these batteries to 14.8, which is a good top side for AGM batteries. You can push them beyond that, but you don't want to do it very often. I mean, I have, and it hasn't hurt the batteries at all. They just do a little off-gassing, you can hear it, and then just, you know, but it doesn't really hurt the battery. But 14.8 is real good, so 29.6 is what we want to try to bring this up to. But let me list just a few things that are interesting that we have to overcome. Let's talk about the friction. Let's talk about what has got to be overcome in order to see any kind of an increase here, because that would just be amazing if we could. So number one, you've got this motor. Now this is actually a gear motor. The back section here is the motor. It's a brushed motor. Here's one of the brushes and the other down here. And so you've got heat, you've got friction. Up ahead of that is the gear head section. So lots of friction there too. So, you know, this is a real power consumer here. Inside we've got the front bearing, the front main bearing with friction, and then back here the rear bearing also with friction. And let's see, aside from that, we've got plenty of Lenz's law counter torque going on in the three-phase axial flux alternator, so you've got that to consider. Then there may be some losses in wiring, and there's three transistors on this little circuit board that controls the motor, so you may have a little bit of loss there. So we've got to overcome all that loss, and that's a lot. That's quite a bit of loss. And on top of that, when this reaction kicks in, I'm going to start in just a second here. When the reaction kicks in and you see this change, at first what you're going to see is you're going to see this as a consumer. Everything here is going to be a consumer, and this voltage is going to drop. It's going to drop, drop, and drop, and then it'll stabilize at a voltage, and then it'll start to rise and rise and rise. Okay, the key to this, now I want you to really remember this. This is the most important part. The key to this is the series parallel connection of this, and then there's a series parallel connection that's coming off of the three-phase. Another very important aspect. This battery typically is going to run this motor, drive the system. The three-phase is going to kick back one phase directly to battery A, and two phases in series to both battery A and B, and of course the ultracaps at the same time. So you've got a real strange configuration of series parallel going on here, but because they're all in series, they're all going to equalize out, and it's interesting how it does it, because these are chemically reactive, so there's a chemical action that's going on in the batteries and an electrostatic action that's going on inside of these ultracaps. So the combination of the two doing that is part of what makes this work so well. So that's the setup. Remember what I just told you. Go back and listen to it again if you missed it. So what we're going to do, aside from all those losses that we're going to have in the motor and the bearings and the three-phase, I'm also going to, when the reaction kicks in, I'm also going to turn on this fan, and there's 4 lights on it, and just so that we can throw away even more power. So I want you to see that, you know, we're really consuming and we're actually throwing some power away. Now granted, this doesn't consume a lot of energy, but it does consume sun. So we want to just throw that away and see if that will keep us going on the right track here. So let's see. I think that's pretty much it. Now this is not a kit. I want to point that out. It's not a kit. It's just a demonstrator of one little aspect of the G1. That's all it is. I mean, all we're doing is just taking this section here and demonstrating what it can do as just a like I said, a side effect. That I considered it that, and isolated it and put it into this particular box. Now the parts that you see, like I said, it's not a kit, it's not one of our kits, just a demonstration of the G1, or just that little aspect of the G1. So the plastic parts, the hardware, and the three-phase are all Quantum Magnetics products. The rest of everything you see here is off the shelf. So this is not hard to replicate. I mean, look, there's only a few parts. but being mostly off the shelf, it's going to be pretty easy for someone to replicate if they're so inclined. So so that's what we're going to do. I've got this set to draw about 1.5 amps or 1.4, somewhere around there, for this motor, because like I said, it's a real consumer. So that's, you know, at 12 volts. So we're talking about that and the friction and the counter torque of the three-phase. So that, again, there's a lot to overcome. And so we'll see what the time frame is. Keep an eye on the clock. Keep an eye on what's going on here. And finally, the other thing is this device and the other devices that I've shown that do the same thing, you know, especially from the G1. All these devices I design kind of in my head, and then I just build the machine. I come back later and do schematics, illustrations, manuals if they're needed, if it's a kit, assembly manuals. I don't have anything like that for this machine because, again, this is just a demonstration of one aspect of the G1. So let's get it started and watch the clock and definitely watch the meter, and let's get going. This switch is for the motor. That switch is for the three-phase. You could hear it when it kicked in. You can see it's pulling about 1.5 or less amps, right around 1.5 amps at 12 volts. Now you can see this consuming. It's going to drop for a little bit. $26.10. So we're still a little bit above 13 volts per battery and cap module. Okay, now we hit the point where it wants to turn around. See, it didn't take long at all. It depends on how you've been using the batteries and whether the chemistry has been activated within the last month or within the last few days, so that time will vary. They like the batteries and the capacitors both. They like to be exercised. Okay, they're sort of like us. They want to be exercised to do their thing. Now you see the voltage rising. Again, that rise is across the batteries and the caps, because they're all acting as one unit. Let's say we started at 26.35. I'm going to write that down. Okay, I think that's pretty much where we were when we started, 26.35 volts. And so now we've gone beyond that and we're on the way up. So let's throw away some extra power. There goes the fan and the lights. Oh, it's out of the frame, but there's two more lights on the top of the fan too. Now, I don't know if you can see in the video, but the current has already come down to, let's see, it looks like the 1.3 or 1.4 amps from where it started, 1.5. As this rises and the resistance is less, you're going to see it drop a little bit more. Now, anybody that's worked with ultracaps knows that unless you've got a lot of current coming into them, they're going to charge slowly, because 350 farads on each of these capacitors inside is quite a bit of storage. But so they are increasing while the batteries are at the same time, simultaneously. We're already over 27 volts. Okay, we've reached 2735, and remember, we started here at 2635, so we're exactly 1 volt over across the source unit. And there we are. I'm going to shut it off now. Now you're going to see the battery chemistry kind of try to stabilize, and it actually continues to rise as it works, especially from battery B. So they're going to stabilize, let the series connection do its thing. It'll come up, but then it'll drop back a little bit. But it's interesting because this process is kind of a use it or lose it type of process. These batteries don't want to have a standing voltage of any more than 13.1 or 13.2 volts. So what they're going to do with this 14.8 is, or more, they're actually going to dissipate that over time. Say 24 to 36 hours, you're going to see all this just dissipate, especially out of the caps, going back into the batteries, and the risen voltage in the batteries, all going to come back down to exactly where you started, or maybe just a little bit more. So like I said, it's sort of a use it or lose it, so we need to figure out how to best utilize this this overage that you have now in the batteries and the caps, and and that's what's on my mind right now. So, you know, and also, if you noticed, this didn't just creep up in a matter of hours, but instead it rose steadily in a matter of minutes. Take a look at the clock, or replay, or look at the time on the video here. So this is interesting. So if anyone has any more insight as to how this effect takes place, please feel free to comment so everyone else can consider it. And I think this ought to be replicated by other people. So you know, let's take a look at this maybe a little bit more in depth. I'm going to write down the voltage here at 2964. So that you can see again that we went from 26.35 to 2964, and you can see it's going to drop a little bit, you know, steadily, and it will over time, but it'll get to a point and it'll sort of just stay there and stabilize. You can use that power now. What are you going to do with that extra power? So you know, there may actually be more to this than I've given credit. Let's find out. Oh, hi, face behind the camera. Thank you.